Good day, everyone. My name is Muhammed Suleiman Abakar, MSK. Today will be our second day. At the same time, we're going to discuss mathematics. Topic: fractions. In mathematics, fractions are algebraic expressions with numerator and denominator. What do you mean by algebraic expression with numerator and denominator? Example, A over B. This is a fraction. A here is called the numerator, while B is called the denominator. This slash is the division line that separates the numerator from the denominator. So based on the magnitude, that the size of the numerator and denominator, a fraction can either be proper, improper, or mixed fraction. When we say proper, we have types of fraction. We have the proper. That's the first one. For example, we have 2 over 3. In a situation where the numerator is less than the denominator, that is 2 less than 3. This is the sign of less than. When you bend your right arm, the elbow point to the left direction. So we now say this fraction is called proper fraction. Improper fraction, let's take the reciprocal of the 3 over 2. In this case, we can easily say 3 is greater than 2. When the numerator is greater than the denominator, we say the fraction is improper. Then the third, the improper can always be changed to mixed fraction. Mixed fraction. In a mixed fraction, supposing we say 2 goes into 3 how many times? 1. Remember what? 1 over 2. In this case, we have a whole number of parts and a fractional part. That fractional part must be a proper fraction. So this is mixed. Why? Because it contains a whole number part with a fractional part. So every single time you are asked to simplify a fraction, always think about the BODMAS. The BODMAS will assist you in simplifying your fractions. In BODMAS, these are a combination of mathematical operators. B stands for the bracket. O stands for half, which is still the same thing as multiplication. D stands for division. M stands for multiplication. A stands for addition and subtraction. Meanwhile, these are almost all the same thing. The bracket, the half, division, multiplication, while this one seems to be similar to in terms of BODMAS. So let's go straight into example so that we see how we can be able to simplify all areas. Topic: you should be able to simplify your fractions, being it in WAEC, NECO, JAM, NAPTEP, post-UTME exams, as many as possible. For example, let's start with simple ones. Supposing we ask to simplify the following. Number 1. Simplify the following. 5a over 8 minus 3a over 8. Look at 2. 5 over 2d minus 7 over 2d. Look at number 3. 7a over 3 plus 2a over 3. Let's go to number 4. 5 over 4c minus 4 over 3d. So let's use this to create a kind of basics with which we can be able to handle all areas of simplification. The first one, solution comes here. 5a over 8 minus 3a over 8. So the first thing you always do every single time you're taking any problems in mathematics is you identify first. Don't just start either handling the problem. No, identify first. First of all, this is a fraction, it's equally a fraction. Unlike the last topic we discussed, indices. In this case, there is no power, there is no base. So what we do here is that to handle this fraction, look at the denominators. Denominators are the same, and the operator here is subtraction sign. So in this case, we think about the lowest common multiple, that is the LCM. The LCM remains 8. How we do 8 goes into 8 one time. 1 times 5a, the result is 5a minus 8 into 8, the same 1. 1 times 3a, the same 3a. So now we can be able to simplify like terms. 5a, 3a, they all contain numeral and variable. The numeral here is 5, variable is a. 5a minus 3a will automatically give you 2a, all divided by 8. So another thing is that 2 is a factor of 8. So we can easily go this way. 2 goes here 1, 2 into 8, 4. So at the end of the day, this will be the same thing as a over 4. We can't simplify further because here these are two dissimilar terms. This is a variable, that is a letter. This is a numeral, that is a number. So the result is a over 4. Let's take a look at the second example. In the second example, if you look at the first example very well, the numerator consists of numeral and a variable, while denominators are all numeral. While in the second example, the numerators are numerals, that is numbers, while the denominators consist of numeral and variable. So the solution comes here as simple as this: 5 over 2d minus 7 over 2d. The LCM, still the same thing, 2d, 2d, take 2d as the LCM, the lowest common multiple. 2d goes into 2d once. 1 times 5, we have 5, then minus 2d into 2d, same 1. 1 times 7, 7. So with ease, we can be able to subtract 5 from 7. But subtracting 5 from 7 will give a negative result. 7 minus 5 is 2. But 5 minus 7 is minus 2, all divided by 2d. In this case, 2 is common here. 2 goes here 1 time, 2 here 1. So the result will be equals to 1 over d. That's negative 1 over d. This negative doesn't belong to the numerator, it's within the division line. So the next again, another example, we have 7a over 3 plus 2d over 3. Solution number 3 looks much similar to number 1. 7a over 3 plus 2a over 3. The denominators 3. Consider the LCM of 3. LCM of 3 remains 3. 3 goes into 3. 1. 1 times 7a, 7a. Plus 3 into 3, 1. 1 times 2a, 2a. So now, we can easily simplify the numerator. 2a plus 2a, 9a over 3. So this fraction is said to be improper fraction. Why? Because the numerator is greater than the denominator. Meanwhile, the denominator is a factor of the numerator. So 3 goes here 1, 3 goes here 3. So the result will be equals to 3a. Then, example 4 looks much different from example 1, 2, and 3, but with much similarities. So, we also simplify 5 over 4c minus 4 over 3d. The LCM of 4 and 3 is 12. That is the lowest common multiple, while the LCM of C and D remains C and D. So meanwhile, the LCM now will be equals to 12CD. So in this case, 4 goes into 12 3 times. 3 times 5, 15. Then C cancels the remaining, C cancels C remain D. So this will be 15D minus 3 into 12, 4. 4 times 4, 16. Then D cancels the leaving behind C. So the problem with this is the numerator consists of dissimilar terms, D and C. And there is no common term to factor out. So at the end of the day, the final result remains 15D minus 16C, all divided by 12CD. Let's take a break. welcome back. We've seen the example 1, 2, 3, 4. There are similarities, the little differences. So now let's take a look at some complex examples with which you now can be able to handle as many problems as possible as regards to fractions. We are still simplifying. Example 5. We are asked to simplify bracket 1 whole number 5 over 8 plus 1 whole number 3 over 5 divided by 5 whole number 3 over 8. Alright, remember always the basic, identify. Don't just start simplification without identifying the question. This question is on simplification of fractions. This fraction consists of mixed fraction. This is another mixed fraction. This is another mixed fraction. So you'll be expected to convert all the mixed fractions to improper fraction first. You have 1 whole number 5 over 8 plus 1 whole number 3 over 5 divided by 5 whole number 3 over 8. So the first mark will be given to a student that be able to convert all the mixed fraction to improper fraction. How? Going this way. 8 times 1, 8 plus 3, 13. 13 over 8 plus 5 times 1, 5 plus 3, have 8 over 5. Then divided by 8 times 5, 40. 40 plus 3, 43 over 8. This is the first step. Then the second step, now you apply the board math. The bracket first. So now you ask yourself, what is the LCM of 8 and 5? The LCM of 8 and 5, some will be wondering, how possible can we be able to find the LCM? You can use a long division method. With that, you can be able to find the LCM. That is the lowest common multiple, a number that 8 can divide without a remainder, 5 can also divide without a remainder. For example, supposing we say 40. 40, 8 into 40, it goes 5 times. Then 5 times 13. You have 13 times 5. This says 5 times 3, 15. 5 carry 1. 5 times 1, 5 plus 1, 6. Here you have 65. Then plus 5 into 40, 8 times. 8 times 8, 64. At the end of the day, still have divided by 43 now over have 65 plus 64, that's 129, divided by 40. And we change the division sign to multiplication while taking the reciprocal of the preceding terms times 8 over 43. So we now consider common factors. 8 goes here 1, 8 into 45. Then 43 here 1, 43 into 129, 3. Then the result will be equal to 3 times 1, 3, 5 times 1, 5. So this is a very good example of proper fraction. The numerator is 3, while the denominator is 5. So let's take a look at the next example now. So we are asked to simplify, let's say example 6. Simplify, open bracket, 2, 1 over 2, plus 1 whole number, 1 over 4, close the bracket, divided by 5 whole number, 1 over 2 times 2 whole number, 2 over 3. So this is another good example of fractions. This consists of mixed fraction. It's another example of mixed fraction. It's another example of mixed. It's another example of mixed. So students here are expected to, first of all, convert all the mixed fractions to improper fractions. So here we have 2 whole number 1 over 2 plus 1 whole number 1 over 4, close the bracket, divided by 5 whole number 1 over 2 times 2 whole number 2 over 5. So how possible can we be able to convert all the mixed fraction to improper? By taking the denominator, multiplying by the whole number 2 times 2. 4 plus 1. Here we have 5 over 2 plus 4 times 1. 4 plus 1, 5 over 4. Then divided by 5 times 2. 10 plus 1, have 11 over 2. Then times the same 5 times 2. 10 plus 2. Here we have 12 over 10. Okay. So, why considering both mass? The LCM of 4 and 2 is still the same thing as 4. Why? Because 2 is a factor of 4, likewise 4 is equally a factor of 4. 2 goes into 4 2 times, 2 times 5, 10. Then 4 goes into 4, 1, 1 times 5, 5. Then possibility of changing the division sign to multiplication while considering the reciprocal of the preceding terms, then times 12 over 10. Okay, now we simplify. 10 plus 5, 15 over 4, then times 2 over 11 times 12 over 10. Another example of common factor here is 2 goes here, 1, 2 goes here, 2. At the end of the day, we'll be expecting to have 15 times 12, all divided by 2 times 11, that is 22 times 10. So, 12, 22. 2 can still divide. First of all, 5 goes into 15 3 times. 5 goes into 10 2 times. Likewise, 2 goes into 12 6 times. 2 goes into 22 11 times. At the end of the day, we have 3 times 6 over 11 times 2. 2 into 6, 3. Then the result will now be equals to 3 times 3, 9 over 11. Okay, let's take the last example on simplification. Example 7. The 7, simplify p open brackets 1 plus 1 over p close the bracket minus q open brackets 1 plus 1 over q bracket closed. Remember, always the logic is always try to identify exactly what is given to you. Secondly, how to start handling the problem. This is simplification. Here we have 2 variables, p and q, with only one numeral 1. And at the same time, while respecting both mass, here we have a bracket. P is said to be the coefficient of this bracket. Q is said to be the coefficient of the second bracket. So to handle this with ease, solution comes here. P into 1 plus 1 over p, close the bracket, minus q into 1 plus 1 over q. What do? We use the coefficient to multiply all the terms within the bracket. Here we say p times 1 is plus p times 1 over p. We expanded this. Then minus times plus is minus, q times 1, minus times plus is still minus, then q times 1 over q. Now we can simplify what is p times 1, p. It's just like a mirror. When you look at a mirror, you always see your image. Then plus p times 1 over p, this is now the inverse of p. A number times its inverse is unity. P, we cancel p, the result is 1. Then minus q times 1 will give you q. Then this minus again. Then q times 1 over q, the inverse. This we cancel, this leaving behind 1. So at the end of the day, we now consider like terms. The like terms are p and q. They are variables within one side, p minus q. Then the numerals 1, then plus 1 minus 1. This plus 1 minus 1. P minus q remain p minus q. 1 minus 1 cancel each other as 0. So the result is now p minus q. So this brings us to the end of simplification. So we hope that you followed each and every one of the steps, the procedure involved, so that I can be able to handle as many numerical problems as possible with regards to fractions. Thank you for watching.